Backtracking still confusing you? In this video, we will break down what is backtracking, how it differs from DFS, how to build a recursive decision tree, and solve a real Leetcode problem using it. If you ever struggled with problems like permutation, combination sum, or Sudoku solver, you are going to walk away from this video saying, "Now I get it." Sit back, relax. I'm CodeViento, and let's master backtracking together. Backtracking is a recursive problem-solving technique used to build up a solution incrementally, abandoning a path as soon as it determines that it cannot possibly lead a valid solution. Think of it like being in a maze. You try a path. If it leads to a dead end, you backtrack and try another path. That trying all path plus reversing process is backtracking. Path, current process or potential solution. Chooses all available decision at this step. If problem is solved, base case condition. Save path at the completed solution. Undo choose. Reverse the last step, backtrack. DFS and backtracking are similar and different. Both use recursion. Both go deep into the problem space. Depth first. Both typically involve tree or graph traversal. DFS is for traversal, just visit nodes. Backtracking is for decision making. Try all possibilities. DFS usually uses a visited set or prevent cycles. Backtracking maintains a path or reverses decisions. Think of it like this. DFS is like walking through a forest and visiting every single tree. You are exploring, but you are not really trying to find a way out. Backtracking, on the other hand, is like being a maze and try to escape. You make a decision at every turn, and if it's a dead end, you go back and try another path. That's what makes backtracking powerful. It's not just visiting nodes, it's building and validation decisions, and undoing them when they don't work. Let's check a Leetcode example together. Leetcode 46 permutations. Given an array of distinct integer, return all possible permutations. Let's check the first example together. Input is 1, 2, 3, and here is the expected output. We will start with an empty list. Pick 1, pick 2, pick 3. Save it. Backtrack 1 and 2. Pick 3, pick 2. Save it. Backtrack 1 and 3. Backtrack 1. Pick 2, pick 1, pick 3. Save it. Backtrack 2 and 1. Pick 3, pick 1. Save it. Backtrack 2 and 3. Backtrack 2, pick 3, pick 1, pick 2, save it. Backtrack 3 and 1, pick 2, pick 1, save it. Backtrack 3 and 2, backtrack 3. Let's check the code together. We initialize an empty list called result that will contain all permutations. We call a helper method named backtracked with 3 arguments. Result the final list of permutation, an empty list path, and the original input array numbers. We return the result list contain all permutations. This is the recursive backtrack function. It builds permutations by choosing one number at a time. If the size of the current path equals the number of the input elements, we have a complete permutation. We add a copy of current path to the result list. We return to explore other possibilities. We look through each number in the input array. If the number is already in the current path, we skip it to avoid using the same number twice. We choose the number by adding it to the current path. We recursively call backtrack to contain building the permutation. We remove last added number from the path. This is the backtrack step. It allows us to try the next possibility. Let's run the test and see the result together. Let's submit the solution and check the result. Time complexity is O(n) factorial, permutation of n elements. Space complexity is O(n) factorial for result and O(n) for recursion stack. In the next video, we will solve another backtracking example together. Don't forget to like and subscribe. Thank you for watching, friends. See you in the next one.